Today I'm going to be doing 4 problems of comparing mean and median, the 5-number summary, and 68, 95, 99.7 rule, and finding value given a proportion. So let's start off with problem 1. These are the following house prices in US dollars in small towns. So the first question is compute the mean and the median. So to find the mean, we calculate all of these together, and then we divide by the number of houses that are there. So we know that all of this together added is 1,796,000. And depending on how many numbers there are, so there's 1, 2, 3, 4, 5, 6, 7, 8. So we divide that by 8 and we get 224,500. This is the mean. Now to do the median, we cross out until we meet in the middle. So cross this out until we meet in the middle. So these two are going to be in the middle. So what we do with a data like that, we add those together. So we do 145,000 plus 150,000 and divided by the numbers there. So there's 2 sets of numbers right here. So to find that is 147,500. And this is the median. Okay. Next question is state which measure better represents a typical house price here and explain why. So to find the median, we already did that. We found the mean. So the median would be a better representative because it's less affected by the 800,000 outlier. Whereas the mean 224,500 is greater because of that outlier. So the median would be a better representative because it is less affected by that 800,000 outlier. Okay. Next question. Explain how the outlier affects your answer. So the outlier 800,000 skews the mean upwards, making it less representative of the typical house price, and the median is unaffected by the outlier, making it an accurate reflection. So what this means is that the mean is upwards and more affected than the median, and the median is an accurate reflection. So we'll just say the median is an accurate reflection. Okay. I will show the first problem we did, which is this one. This is the one we just did. Okay, now we are on to problem 2. And I will put this up. Okay. So for problem 2, these are the exam scores right here. And the first problem, we need to find the 5-number summary. But what is the 5-number summary? The 5-number summary consists of 5 different applications to these. So we have the minimum, we have quartile 1, we have the median, and then we have quartile 3 and the maximum. So we can go ahead and find minimum, maximum, and median easily. We know that 55 is less than any other number, so we know that's the minimum. And then we know that 95 is the max of this data set. So 95 is the max. Okay, then to find the median, we do what we did in problem 1. We cancel out until we meet the middle. So we'll do that real quick. And we know that is 70. Okay. And then to find quartile 1, we know that this is the median, so we box that out. And this whole side right here is quartile 1. And then we know this side is quartile 3. So we basically do what we do with the median. We cancel out until we meet in the middle. So we know that the quartile 1 is 62. And then we do the same thing on quartile 3. We cancel out until we meet in the middle. So we know that's 80. And that is your 5-number summary. Okay, question 2. Compute the IQR and identify suspected outliers using the 1.5 times IQR rule. So first what we need to do is find the IQR. And to do that, IQR, to calculate that, we do quartile 3 minus the Q1, which is quartile 1. And we know that quartile 3 is 80 and quartile 1 is 62. So we subtract those and we get 18. Okay, so now that we know the IQR, we can find the outliers using the 1.5 times IQR formula. So 1.5 times the IQR of 18, and we will get 27. So how do we find the outliers now? So what we do to find the outliers is we take the quartile 1, which is 80. Oh, sorry, quartile 1 is 62. 62 minus the IQR, which is 27, and that will end up equal 35. And then to find the other outlier, we get quartile 3, which is 80, and we add 27, which will equal 107. Okay, these are the outliers. So what this means is that any value less than 35 or greater than 107 would be suspected as an outlier. Okay, on to question 3. Draw a box plot based on your result and describe the shape. Okay, so to draw a box plot, we draw a line, 2 ends in the box, the line for the median. So we know that this will be the minimum of the data. So we know that's 55 from our 5-number summary. And then the maximum, which we know from the 5-number summary, is 95. The 5-number summary will really help with this box plot and make it easier to plot the data points. So we know the quartile 1, we know quartile 3, and the median. The median right here is 70, and then we have quartile 1 and quartile 3. And those will be 62 and 80. So this is the box plot for this data set. And we know that these two are further apart than this side. So what this means is that it's a slight right skew. Slight right skew of this data set. That is for problem 2. And now we will go on to problem 3. I will show you the problem for this one. problem 3. Okay. So problem 3 is package weights shipped by a company are approximately normal with mean of 12 pounds and a standard deviation of 2 pounds. So I just went ahead and wrote this down for my problem. So problem 1 is, what proportion of packages weigh between 10 and 14 pounds? So we need to figure out what weighs between 10 and 14 pounds. Okay. First, we need to convert the endpoints to z-scores. So to find the z-score, we do 10 minus 12. We're first doing this point, 10, minus the mean, 12, divided by the standard deviation of 2. And that will equal -1. Now to find the 14 scores, we do the same thing, 14, but we use 14, minus 12 divided by 2, which will equal 1. So, and now we go to the table, and we want to find 1 on the table. So, this is what the table looks like. So, whenever we find 1, we know that we know that 1 on the table is 0.8413. And we can find that by going on this side of the table. 1 equals 0.8413. Okay. And then after that, we're still trying to find the weight between 10 and 14 pounds. So what we need to do to find that is multiply 2 times 0.8413 minus 1. This will end up equaling 0.6827, which in percentage is 68.27%. So this answer is what packages weigh between, what proportion, this is the proportion that weighs between 10 and 14 pounds. It is 68.27%. Okay, now on to question 2. What proportion weigh more than 16 pounds? So we're finding more than 16 pounds. Okay, so we know X is 16. And to find Z, we do 16 minus 12, which is the mean, divided by 2, which is the standard deviation. And that will end up equaling 2. Okay? So whenever we use the 68, 95, and the 99.7 rule, we know that 99.7 rule and all that, about 95% of the values will lie within that. That means that 5% lie outside that band. So 5% lies outside of 2. And that will end up equaling 2.5%. So now on to question 3. Use a briefly justify the 68, 95, and 99.7 rule for your answers. I will be showing a bell curve, so let's go ahead and draw that out. Okay, so we know that our standard deviations are 2 away from each other, so we'll do 8, 10, and then we have 12, 14, and 16. 12 is our mean, so 12 will go right here, and then we have 8 and 10, then we have 14 and 16. So we know that 68.27% lie between 10 and 14 pounds. So let's go ahead and mark between 10 and 14 pounds. And this is 68%. Okay. And then we have less than 16 pounds. So this is where our 2.5% is at, because it is less than 16 pounds. All right, that is problem 3. On to problem 4. This is problem 4. Okay. Problem 4. Assume SAT math scores are normal with a mean of 500 and a standard deviation of 100. All right, for the first question, find the score that marks the top 10% of students. So we know the mean and we know the standard deviation. So what top 10%? So we have top 10%, and we're trying to find the scores that mark the top 10% of students. So we know that 10% is the 90th percentile. Which equals 0.90. So if we go on the table and we find 0.9, we know Z will be 1.28. So we're trying to find the closest data to 0.9. Here. So this is the closest data to 0.9. So it's 1.2, and if we go up, 1.29 is close to 9 and 8, so we 1.28. Okay. So we know that Z is 1.28. So to find top 10% of students, we will do X equals the mean plus the Z and times the standard deviation. This equals 500, which is the mean right here, plus 1.28 Z times 100, which is the standard deviation, and that will give you 628. And that is the answer. 628 marks the 10%. Okay, now on to question 2. Find the score that marks the bottom 25%. So we just found the top 10%. Now we're finding bottom 25%. And that is the 25th percentile. Which equals 0.25. And then if we find 0.25 on the table, we know that whenever we find 0.25 on the table, we know that z equals negative 0.674. And then now we have to find the bottom 25%. So we do x, the same formula up here, 500 plus the negative 0.674 times 100, and that will end up equaling 500, or sorry, not 500, 432.6. So we'll round that up to 433. 433 marks the bottom 25%. Okay, show your work, convert to z-scores, use a standard normal table recalculator, and translate back to the original scale. So we did that with this. That is it on my 4 problems on comparing the mean and median, 5-number summary, the 68, 95, and 99.7 rule, and finding a value with a given proportion.